In Chapter 5, we're going to talk about rings. Now, we've just left off talking about stereochemistry, and we haven't paid that much attention to what happens when you have an alkane ring. And so what we're going to notice is that when an alkyl chain forms a ring, then the molecule is more constrained and there's fewer conformations that are available. So we're going to take a look at both conformations, harkening back to the previous chapter, and we're also going to take a look at stereochemistry, harkening back to the previous chapter. So one of the things that we want to think about is that when conformations arise in rings, then they try to maximize stability. And the question is, well, what types of conformations maximize stability? So these are some of the things that we are, I say, going to ponder. The first thing, how do we represent the shape of rings? And how do we represent the positions of substituents that are on the ring in space, three-dimensional space? So that's one of the first things that we're going to think about. What does an actual shape of a ring look like? Obviously, we've been drawing rings in some planar geometry, but in reality, they are not planar. A second thing to think about is how flexible or how rigid rings are of various sizes. And from that rigidity or flexibility, what possible conformations arise from this? And so we're going to see that some rings are more flexible than other rings. And so what happens in terms or in respect to that flexibility? The third thing that we want to think about is what happens to the position of substituents when a ring actually can change conformation. So we've already seen that alkanes can undergo conformational changes. We've looked at how to analyze the energy of those conformational changes. But when you have a constrained system, a ring system, what happens to the substituents when the ring changes conformation? Can we visualize what's going on in that process? And can we think about the stability? Are substituents more stable in certain conformations than in other conformations? And then lastly, what are sources of strain that are built into rings? And we're going to talk in much greater detail about that throughout the chapter. Now, before we really dive into the structure and the shape of rings, there are certainly some must-haves when it comes to really understanding what's going on. So you must have a good visualization of 3D molecules in two-dimensional space. Now we've already explored this idea talking about stereochemistry, and if you're still struggling with this, I cannot stress this enough. You need to invest in a model kit. Model kits are a staple of organic chemists. We all use them, and so the more that you spend time looking at a molecule in three dimensions, the better understanding you have later on.